So today we're going to learn the difference between speed and velocity. This is section 1.8 of your book. Speed is given as distance divided by time. So is velocity. Those are going to be the same units you have, but speed is what's known as a scalar. Okay, something that is a scalar only has a size associated with it or a magnitude. However, velocity is a vector. A vector not only has a size or a magnitude, but it has a direction associated with it as well. So the calculation is going to be the same, but whenever you're talking about velocity, you're going to specify a direction: north, east, southwest, up, down, positive, negative. You're going to put a direction after those units of, say, miles per hour or meters per second. So anyway, this is the equation for speed. Speed equals distance over time. And you can use any combination of units for this. Okay, so if we're looking at speed and we're looking at units, one you're probably really familiar with is miles per hour. It's what your car has on your speedometer. If you're traveling in Canada or Europe, you're going to have kilometers per hour. Kilometers, 0.6 miles. In this class, we're going to be interested in units of meters per second. Remember, meters 39 inches, a little bit bigger than a yard. We could have feet per minute. All sorts of crazy combinations, but the point is that it's always a distance, miles, kilometers, meters, or feet, divided by a time, hours, seconds, or minutes. And you can change these from one unit to another. If a car is going 70 miles in 1 hour, it is also going 1.17 miles in a minute. And converting that even farther, it's 0.0194 miles in a second. Okay, these are all the same speed. They're just different units. We're much more familiar with this one, but we can talk about miles that's traveling in a minute or miles that's traveling in every second. We're just not talking about direction. So let's do a couple of problems. Your book makes a point about talking about instantaneous speed versus average speed. Instantaneous speed is what you read on your car speedometer. You might be going 60 miles an hour, then 61, then 62, then drop down to 59. That's an instantaneous speed. If you're trying to keep an average of 60, you're doing a fairly good job. If you're traveling for any kind of distance, then you're talking about average speed. And mostly what we're going to be working with is average speed. So let's calculate one. So we're looking at average speed here. Whoops, I still can't spell. And I want to know how long it takes, what the speed of a car is if it takes us 1.45 hours to travel from St. Joseph's to La Jolla. A distance, according to Google Maps, of 99 miles. Okay, so we're going to use the equation up here. Speed is distance divided by time. We know the distance is 99 miles. We're going to divide by the time, 1.45 hours. Doing the division, I got 68.3 miles per hour, which would be nice if you could do it going to San Diego these days. Okay, so easy enough. Now, sometimes you're asked to find a distance or you're asked to find a time. So if you know speed equals distance divided by time, then we know speed times time equals distance. And we know that time equals distance divided by speed. So just depending on what you want, you have three combinations of that same equation. If you're not good at rearranging, write those down. So we have a car, and the car is traveling at 60 kilometers an hour. For 3.5 hours. Gotta do that again for 3.5 hours. And I want to know how far that car went. That would be how far did it travel? Okay, how far means I'm looking for distance. So I'm going to be using this equation, speed times time equals distance. The speed is, okay, so we have distance equals speed times time. So we know that the speed is 60 kilometers in every 1 hour. And we traveled for 3.5 hours. So the units of hours will cancel, and we're going to multiply 60 by 3.5. If I do that, I have 210 kilometers, or switching it to units we're a little bit more familiar with, it's 126 miles. Now, these have been speed problems. What about velocity problems? Let's take the St. Joseph to La Jolla problem that we just did. What's the velocity? Well, you already know the speed, right? We calculated that. It's up here somewhere. So all I need to do is attach a direction to it. We were going 68.3 miles per hour. If you are traveling from St. Joseph to La Jolla, you are going south. That's the velocity. If we're going from La Jolla back to St. Joseph, and we just happen to be traveling at exactly the same speed, we would be going 68.3 miles per hour northward. So that's really all you have to do to go from speed up here to velocity down here is attach a direction to it. Next time we're going to do acceleration, which is a little more complicated than this.